I hope in the previous concept, what was our previous concept? Linear algebra. So what are the functions we used in last class? Come on. Outer of, inner of, dot, solve, inv, trace. Trace. Who said trace? Trace. Trace. What is the trace? Principal diagonal elements. If we add it, that is called what? Tracing. Right? Let's move to the further. So here, that is an important students. Linear algebra concepts are important. Let me move to the further. Today, I want to introduce some universal functions. Universal functions on Numpy, ND array object. And next, Numpy with files also will be there. Numpy, how to save the Numpy data, how to retrieve the data from Numpy. All those things I'll discuss. So, I'll go to one more thing. I am going to talk about universal functions are there. Universal functions. There you are having, and that also very regularly coming across questions, universal functions that are very, very easy. Just look at once. What are those things you know, students? So, here if you look at number one, discrete differences, I want to talk. Next, GCD, that you are already aware of it. And GCD means your school days one thing, that is important, plus something more. Next is called LCM, LCM of your school days, and more about the LCM about it. Set operations, summations, products, rounding, and simple arithmetic. These are the universal functions on where? ND array. What are the universal functions on ND array? They will ask. You have to tell all these things. Discrete differences. Have you heard about discrete differences? Do you know any time have you heard about in our mathematics? 10, 12, 13, 15, something like this. 10, 10, and 12 minus 10, 12 minus 10, 13 minus 2. Next, 13 minus 15 minus 13. Like that. Differences between two consecutive numbers. They are called what? Discrete differences. So let me go to the discrete differences, because if I show you that, you will be understanding the mathematics related things. If I show you the documentation, you will understand. I feel it. That's why I prepared a good documentation for you. Try to understand. A very easiest documentation I prepared. Try to follow. What is the topic now? Numpy discrete differences. This is called what? One of the universal function of Numpy. So you will come across all these things in the data science related calculations. A discrete difference means subtracting two successive elements. Discrete difference is nothing but what? Subtracting two successive elements. What are the successive elements? 1, 2, 2, 3, 3, 4. They are called what? Successive means one after the other. The discrete difference would be, come on, 2 minus 1, 2 minus 1. Next, 3 minus 2. Next, 4 minus 3. That is known as what? Discrete difference. 1, 1, 1 is called discrete difference of these elements. Discrete difference of these elements. Are you able to follow? Right. Next, I'm going to take up another kind of thing. Find the discrete difference. To find the discrete difference of this kind of data like that, we use which function? Diff function. Spell out diff function. So compute discrete difference of the following array. Right? You know, importing, taking an array, finding the discrete difference. When you get a requirement of finding the discrete difference, we will take this Numpy and we will use what? Difference of. You will find this kind of data. Are you able to follow? So today, a lot of less students are there. Huh? Underground. Huh? Okay. These days, people are started going from Friday onwards. Friday onwards, underground only. Friday evening onwards, they went to underground. So Saturday, deep underground. Sunday they will night come out of their underground. Monday rest. Tuesday they will come again. Tuesday, Wednesday, Thursday. Only 3 days. After 2 to 3 years, complete underground only. Nobody will be there. That's why people are just roaming on the roads. Really, students, you don't know. Of course, you can't find out also. Things are very different. Not reading. Without reading, want to get the job. Just now one student came. Well, I'm ready to go for breakfast. My friend came. And if my student came, along with him, his friend came. He is already doing some business, it seems. He said some story to me. Sir, I want to learn Python, but practice everything required, is your student said. And sir, I have business and everything I have to take care. Only by listening class will I get the job. I said, better to do your business. Give an opportunity somebody to work in your business. Don't learn Python, I said. Openly, I said to him. Because if he learn Python, he is also competitor unnecessarily. And without practicing, what he will get it? So, are you practicing daily? Huh? Who is not practicing? Just I want to find out. So, Saturday, a little relax, I speak to you. Both boys and girls. You should not tell to me lies in the class. Who is not practicing? I'm not going to say anything. Raise your hands. Who is not practicing? Boys, you tell me. Girls, well, etla cheptaru because they are sincere. First, boys. They are asking that only. Sir, first ask boys. No problem. I want to see your faces. Who is not practicing? Raise your hands. Don't tell lies, I said, no. And why you are not raising hand, feeling guilty, right? Others may feel that who is this guy? Who is not practicing? Everybody practicing. Who is practicing? Raise the hands. I will ask some questions. Raise now. Who is practicing? Okay. Now I understood who is not practicing. Some of them did not raise the hands. Okay, girls, who is not practicing more? Nobody. Means accepting. Accepting. Not practicing, not raising the hand. Who is practicing? Okay. Few of them did not raise their hands and still they are not practicing. Okay, students. So now I will move to the further. Right. So somebody, so Subha, Ganesh Bobby is saying, sir, lots of members are not having laptop or PC to practice. Okay. So Nirkar Behra, I have now 10 hours class. Then after class, I made my notes, everything. Okay. So Shubha Ganesh Babu is saying, lots of members are not having laptop. My advice is, instead of buying 30,000 mobile, and losing your memory, you buy one 1,000 rupees mobile, one button mobile, you buy it, and rest of the 29,000 buy the laptop, so that every member will have a laptop. Correct or not? And your mobile cost is almost 30,000, at least 25,000, whatever it is. 10,000 at least. At 10,000 laptops are there. You can buy. You can buy. You can practice. Okay. Now come to the point. Okay, Ganesh Babu, I said to you the answer for that. Because of laptops not there, not practicing, that is not the way. So if there is a way, if there is a will, there is a way. You know that. Anyhow, come. So if I go on talking like that, lot of stories will come. So are you finding the discrete differences here? Discrete differences, you are getting it. So I'm going to take up this entire discrete differences like this. You see this discrete differences, you got the data. And one more kind of discrete difference. We can perform this operation repeatedly by giving parameter n also. For example, 1, 2, 3, 4, discrete difference with n is equal to 2. What the meaning of 2 would be 2 minus 1, and you are giving the number itself. You are giving the number itself, n is equal to 2. 2 minus 1, next is called what? 3 minus 2, and next is called what? 4 minus 3. 4 minus 3. This is the 1. Since n is equal to 2, we will be doing once more, and the new result will be what? What is that? One more time. N is equal to 2 means what? 2 times discrete events. 2 times discrete difference will find. This is the first time done or not? That is called n is equal to 1. Now n is equal to 2. Meaning is what? 1 minus 1, 0. 1 minus 1 is called what? 0. That is also going to be second time discrete difference, I think. Are you following? By default, n is going to be called what? 1. But I am giving n is equal to what here? 2. Because of this 2, n is equal to 2. What is happening? First time discrete difference here. Here I said a or r comma n is equal to 2. What is the first time discrete difference? Come on, 10 minus 15 minus 10, 5. 25 minus 15, 5 minus 25. Come on, 5 minus 25, minus 20, minus 20. But what is this n is equal to? 2. Next, come on, answer. Next, 10 minus 5, 5. Next, minus 20 minus 10, minus 30. That is an answer finally. Are you getting this final answer? So discrete differences you can find any number of times, depends on your requirement. So let me go to the discrete differences example here. Go to this place, and these are very easy. Don't take much time. I want to complete multiple universal functions today. So let's take online students. I hope you got it. So online also, almost 84 students absent in online. Only 300 members are there. 84 students are absent. Offline also same thing. So coming to the point back, discrete differences. We'll go for this discrete differences. Here I am going to take up. Done. Here I am going to take up. Import what? Numpy as NP. So you take that discrete difference directly. Take this requirement as it is. And find the new array you print it. New array you try to print it. Discrete difference. And you are getting the data called what? 15 minus 10, 25 minus 10, and then 5 minus 25. You got the data. And next is with what? We can perform operation repeatedly by parameter called what? N. So discrete differences, compute discrete differences for this kind of result. So I'm trying to carry this type of things. So I'm going to give you a comment here. Compute discrete differences of the following array twice, where n is going to be called what? 2. So that n represents what? Discrete difference. So try to same diff of array n comma 2. So you are getting the answer called what? 5 and then minus 30. Are you able to follow? First time discrete difference is called something like that. First time discrete difference you already got it. And n is equal to 2 you are writing. N is equal to 2 you are writing. You are getting that. If I write n is equal to 3, what will happen? Minus 35 is an answer. Are you getting? And don't expect minus 4. So here I am going to take. So 2 if I say, you'll get 2 times discrete differences. So compute the discrete differences 3 times. Thrice. So I'm writing here. Thrice. I'm going to take it. N is equal to what? 3. So you are getting the answer called what? The same thing we are going to get it. Easier? Simple. It's very simple. That is about discrete differences. So people will ask you about this. Next, I'll go to one more. GCD. In GCD, there are 2 functions are there. One is called what? GCD of 2 numbers. GCD of 2 numbers we can find. GCD of 2 numbers you can find. And GCD of what? GCD of what? 10, 15, 20, 35, 66, Like that, many numbers you can find. And this is little important. And this is very simple. What is the 10 comma 4? What is this now? 4. What is this now? 4 2 ja what? 8. What is this now? 2. Again, what is this becomes 4. And what is this now? 2 2 ja 4. 0. This 2 is called GCD or not? Tells you the GCD of two numbers. And this is called what? GCD of that. So how to find out? There are two functions are there. Two values are there. There is a function called GCD of. More than two values are there. NP dot GCD of GCD dot. There is a function name called reduce. There is a function name called reduce. Already you learned in my class reduce function. In my regular Python classes, special functions in Python, filter function, map function, reduce function. That is why I said that reduce function there itself, because you are getting very easy. Suppose if I did not explain that reduce, today I would have been skipping that. No, I don't want. You know already reduce, right or not? So multiple values are there. Find the GCD of these two. Find the GCD of the result and this one, and finding the GCD of everything like that. So how many functions here? Two. One is np dot GCD of two values. Next, np dot GCD dot reduce of group of values. Very, very easy, automatic. Come on, read out. Numpy, GCD of what? Numbers. So, your favorite answer, right? Finding GCD, your favorite answer. Next, the GCD, also known as what? HCF, highest common factor, is the biggest number that is a common factor for both the numbers. And I need not to tell you mathematically. Find the HCF of the following two numbers. HCF is also called what, ma? GCD. Import numpy as np, num1, num2, np dot GCD of num1 comma num2. And the GCD will be called what? The value is called what? 3. What is this now? 9. And what is this now, students? 6. 6. And what is this now? 3. And what is this now? This will become here 6. And 3 3 is what? 6. 0. Sorry. 2. 3 2 is what? 6. And this 3 will become what? GCD. GCD. Are you following that? So, how to do that? GCD of. You can write a normal Python program also, but it takes quite different or not? Lengthy. That's why I'll straightforward go for what? Use NumPy and find. Is the 3 is a GCD or not? Yes. Go to. Very, very important. This I will give the most preference. GCD of arrays. GCD of what? Two numbers. Only two numbers. But more than two numbers I am having. GCD in arrays. To find highest common factor of all the values in an array, that is ND array, you can use what function? Reduce function. The reduce function will use the U function. U functions. They will ask like this in interview. U functions are nothing but what? Universal functions. Utility functions, somebody will say. Even I said, with the beginning days, when you go for the static functions in whoops and all, they are doing utility operations. Utility means what? General operations, universal operations. Utility functions are universal functions. In this case, GCD function, each element will be finding, reduce the array by one dimension. I will explain it. I will read out once again. How do you call it? Here you see ND array here, and finding what next? 20, 80, 32, 36, 16. And what is this now? NP dot GCD of what? Reduce of array. What is this reduce function will do? Already I said in my classes, a beautiful explanation for you. If I go to that, any class you take it, 7 a.m. If I go to special functions in my class, there is a, see, filter related examples, how many? Filter related examples. Map related examples, you see how many? Map related examples. You see next called what? Reduce related examples, you see these many number of things. So if I go back to this example, Reduce function I will open once. I said what is the use of reduce function? How reduce function internal flow is. That internal flow will help you here. That internal flow will help you here. And reduce function internal diagram also explained. Internal flow also explained. Generally, most of the people will not. But here you see. Reduce function internal flow. The group of values are there. The group of values I am going to bring into what? A single result. What is my business logic here? Sum by using reduce. These two values are added here. 30. This 30 with what? Next consecutive element. 30 plus 30 is called 60. That 30 plus next consecutive element is 60 plus 100. 100 plus what next? 50. What is this data called? 150. This is about concept of what? Reduce. So reduce function will give you single element from group of values. Okay. So online students, any other batch students are present here. They need to understand the reduce function. Such a reduce function concept we are using today. Such a reduce function we are using today here. Are you getting? So let's start with GCD of this part also. I will continue. Here I am going to take up, go to this place. Here I will take it. Here I'll take new. Here I will take separate HTML files I'll send so that you can start working on it. So here I am taking GCD of that to take up GCD of it. Try to, here I am trying to say import Numpy as NP. Now I will take it. This data you get it. This data you get it. Now try to find out. Here I'm going to get this data. And how to print it? You got 3. Similarly, you go for what? You go for what? In place of that, you can apply. You can apply 10 and 4. You write it 10 and 4. I did the calculation for you. What is this now? Something like this. You can write it GCD of GCD of. So first value, comma second value is equal to resultant value. You can write format of what is this now? If you want to take care of those values also, x comma y comma z, you can write it. And I can say here x is 10 and y is 20, y is 4 and z is equal to what here? Like this. You can just go for printing the data. You're able to follow this. Something like this. So this is related to what? GCD, how to find out. So here also I will try to print like that. So here x, here y, and here z. Try to find out this. Also getting something like this. This is for what? 2 values. 2 values. So how you got the GCD also? I already said to you just now. So you can do normal Python code also. If I write a normal Python code, I have to write 6 lines of code. Definitely it is a burden. Why can't you directly go for what? GCD. Next. I'll go for a group of values. How it works. Finding the GCD with an array. So how to find out? I'm going to take up this data and I'm going to use it. Go to the place. Here I'm trying to use it. Finding the GCD with an arrays. What is the concept behind that? What is the theme behind that, students? What is the theme behind that? When I'm going to say, this is my data, I take up the diagram of our Python class. 20. What is this now? 8. Next is called 32. Next is called what? 36. Next is called what? 16. And first what is applied here? GCD will find. GCD will find. 20 and 8. 20 and 8. 20 and 8. What is this now? 8. 8 to the 16. 4 and 8. What is this now? 4 to the 8. The remainder 0. This will become. What is the answer now? 4. See all of you. 4. And 4 and what again? 32. What is the answer? Come on. 4. Blue shirt. Stand up. Oh, stand up. No, you are good. Yes. Say the GCD of 4 and 32. Stand properly. 4 and 32 GCD, how much? 4 and 32 GCD, how much? Huh? 4. Etla? How? When everybody is saying, you don't say like that. Don't copy. How 4? 4 8. 4 8. ఇక్కడ లేదు కదా మరి 28. What is the GCD? GCD calculate చేయడం వచ్చా? Do you know how to calculate GCD? నాకేం నీకు వచ్చినట్టు ఏం తెలియట్లే. Follow the class. Come here. Take your books. Now come on. What is the answer now? Come on. 4. 4. Now 4 and 96. 36. Come on. 4. How 4? 4 9 ja. 36. 4. Next 4 and 16. 4. So what is the total GCD of that? 4. Is it reduced to this entire thing is reduced to a single element or not? This is the meaning of what? When a group of values are there, how to find the GCD? That is the answer of it. Now, need to listen the class. So once we come to the class, we have to utilize the class. So I'll print what now? Print of, what is this now? GCD of, I'll take it, is equal to, I'll say like this, dot format of what? ARR comma what? X. ARR comma X. Are you getting or not? So how this reduce function is working? That is an important. So I'll print here type of, what is this? NP dot GCD is equal to type of what? GCD. NP dot GCD. NP dot GCD. What is the type of NC of GCD? UFUNC. It is not a submodule like yesterday. NP.linALG I written. What is the linALG? Submodule. What is this GCD? Universal function. Already we applied as a function or not? UFUNC is also called what? Class. In which place? Numpy. Numpy. Are you able to follow? That's why you try to have print of what? Type of what? NP dot what? Random. NP dot random. Type of that also you try to find out. NP dot what? Random. Random. What is that is called? Module. What is NP? Module. What is the random? Submodule. What is NP? Module. What is the linALG? Module. What is the GCD? Here. UFUNC. Already you know function class. UFUNC is called utility function call or universal function call. Understand? So when all of a sudden they ask, what is NP dot LINALJ dot solve? What is linALG? What is NP dot random? Should have spontaneous answer. If they say that wrong, you open your laptop and show that this is the correct. So you will feel, suppose if you say correct, you say wrong. Who is the answer for that? Open the laptop. That's why go with a laptop. And if you don't have energy, you cannot carry a laptop also. This is after all how much weight is there. So that's why you do this kind of things. Able to follow? Right. Students, what are the two functions to find the GCD? What are the two functions to find the GCD? NP dot GCD of two values. One more is NP dot GCD dot what? Reduce. So that reduce will do what? Two values will be supplied to GCD. Next consecutive element will come like that. How GCD dot reduce works, already you know, today also I explained it. So, Suresh, good. So, I think you are understanding the meaning of what? GCD of the numbers. Let's move to the further. Here you see, to find highest common factor of all values in array, you can use reduce method or reduce function. Generally, we are calling it as a method in whoops, because according to the concept, what is this GCD called? UFUNC. It is called what? Class. Inside the class, there is a function called what? Reduce. The function in whoops is known as method we can call. Anybody whoops did not complete in my classes, I am going to explain that. Those who completed whoops already they know that it is a method. Inside the class, if any function is written, that is a method. Without classes, if I write, that is called a function. That I will give the clarity. If there is a method, you think that it is a function, nothing problem. The reduce method will use UFUNC. That is a GCD function. In this case, GCD function uses the UFUNC. That means it uses GCD function on each element and reduce the array one dimension. It brings to one value only. Are you getting? So even I wrote boxes, I wrote it. And this boxes, first to find the GCD, got the result. This element, got the result, got the element, and got the element, and finally get one result only. This is called single element is coming. That is the meaning of what? A reduce function. That is more clear, I think so. This is one thing I will do it. Next one is going to enter into the further UFUNC. I will go to it. There I will go for next set operations are there. Set operations. By seeing today now, you will see, sir, how easy Numpy is. Everything you will get as it is. In set, in our classes, in our Python classes, if you remember, it's a marvelous discussion. Already made it. We go to 7 a.m. or any class of yours, there is a data types. There is a data types. In the data types, there is a set data type, set, concept of set, properties, what is set, notations of set, types of set, operations on set, predefined functions in set, inner sets, combination of sets with a tuple. These are the examples. Nobody will cover. Nobody will cover. That I covered it. Types of sets and examples on this area. And after that, that is only the concept basis. Predefined functions in set. Add. Next is called what? Remove. All these things will come now. But how easy Numpy is once you know data types. I said data types is very powerful in Python. Pop. Next is called what? Clear. Next is called a copy of. Next is called a disjoint. Superset. Subset. Next is called what? Union. Union will come. Intersection will come now. Next is called what? Special points I said. Special examples. Difference. Next is called symmetric difference. Next is symmetric difference underscore update. Update function. These are all explained. Bitwise operators also used on that. After seeing that, now you see Numpy, how easy it is, how you feel very easy. Go to the place. Now start. I never explain anything. You only start doing that. Okay, 1 minute. So here, I'll go to the place. You enter into that. You enter into this area. Go to the place here. In this case, UFUNC. There I will go for set operations you see. Come on, basic for the students who are newly coming. What is a set? A set in mathematics is a collection of what? Unique elements. This was already explained. No? Set allows unique elements. List and tuple allows what? Unique plus duplicates plus all types of elements. If you are already my student, data types, nothing today. Now, sets are used for operations involving frequent intersection, union, and difference operations. Let us start. Create sets in Numpy. Create sets in Numpy. Come on. We can use Numpy's unique method. That is a unique function to find unique elements from an array. ND array contains some duplicates also, no? So example, create what? A set array. But remember that set arrays should be only 1D arrays. There is a flattening. Even 2D is there. Flatten. Flatten is there. The Ravel is there. You can use. Or you can use ND array dot shape of is equal to total number of elements, comma, you can use. Convert the following array repeated elements. Convert the following array with a repeated elements to a set. Come on. Import NumPy as NP. Now I'm going to take it. NP dot array of. What is this answer you see? NP dot unique of what? ARR. What it prepares? What it prepares? It prepares all the unique elements. One set will be prepared. What is the answer? Right. 3 ones are there. 1 2 is there. 1 3 is there. 1 4 is there. 2 5s are there. 1 5. And then 6 7 will be coming. Are you able to follow? So simple, students. Now I am going for what? Set operations. Go to this place and try to take out a new. I'm taking new notebook. Here I'm going to take it. Set operations. Here. There I will take off. There I will write it. Done. Take this data. So I will take this data here as usual. Come out of that. Import Numpy as this one. What is this now? Unique set. So I'm going to take it what? Unique set is equal to, comma, I'm writing here, X. Even though ND array update is containing like that, I am applying which concept? Unique. Earlier, what is happening? We used to convert this ND array object into what? Set. If a list is containing duplicates, to eliminate the duplicates, I used to go for what? Set. You can write the code also with one unique. You can write the code also. So that code also I already explained in my class. Did you remember that? Look at once. And even if you are intelligent, you can write the code for this unique. Just I will show you. Code. I am just writing here like this. You need not write it just to express your intelligence. Code for which function? Unique function. How it works like? I will take it for value in ARR. For value in ARR. What I do? I'll take one LST. I'll take one LST student. LST. Which LST? Empty. I am taking. If value in LST, value not in LST, not in LST. What is the value first time coming? What is the value? 1. 1 not in LST. Membership operator I am using. True na false? True. Append that. What is this now? LST dot what? Append of what? Value. That's all. Finished. Next time where it is going to? Loop. What is the next value? Second one. 1 not in LST. False. Because already LS1 is containing. Go to next. What is the next one? Another one. Value not in LST. False. Go to next. What is the next? 2. 2 not in LST. Append. Next value. 3. 3 not in LST. Append. 4 not in LST. Append. 5 not in LST. Append. Another 5 not in LST. False. 6 not in LST. Append. 7 not in LST. Append. So finally I am going to take it what? Print of what? Unique elements. Unique elements is equal to what? LST. I'm getting answer or not? Here also same answer. Here also same answer. Here also same answer. Here also same answer. Code for unique function. If you want, you can write it. DEF, KVR unique. You can take like this. So UNI, something like this, you can write. A function UNIQ like this. You can say this data. You can pass ARR here. ARR. This kind of thing. You try to get it. In this place, you try to execute. So what happens? Indentation, I need to take care. This you take care. And you try to do. This is a function created. Indentation, yes. So this is a one. Function created. You call the function KVR unique. This function you call it. And pass your data. What is your values, ma? What are your values? Take in the main program. Here you take in the main program. Pass what here? ARR. Are you able to get or not? So, are you able to follow? So Prashant, sir, you can write program, don't copy paste, sir. This is my program only. I have 100% copyrights activity. I'm going to do that because he is feeling difficulty in understanding the code. That's why he is feeling like that. This already I explained in my Python coding. This is a code. My code I can copy. My copyrights are 100% reserved. KVR will not copy paste anytime. KVR will create a trend in Python. Myself, I am writing my code by myself. I am copying. Correct or not? Are you understanding, Prashant? Right. Done. Are you able to follow, students? Fine. So next I will go to one more thing now. Okay, students, are you getting confused in copy paste? Nothing confused. If you did not practice, even if I write A also, you will get YA. That is the point. Go to next. Did you understand? Unique elements, you got it. Next, I'll go for what? Finding which one? Union. This example, this type of concept, I already said in childhood days only in Python classes. So that kind of code is not a difficult. I'm using this a programmer defined function. Programmer defined function. Defined function. Written. Now to test your intelligence, which works like which function? Union function. Unique function like. Next, come on, speed up. Finding what? Union. Find the unique values of two arrays. Use what? Union 1D. Union 1D. It is nothing but a union only. Come on, start with. See that. Import numpy arr1 np dot array of 1 2 3 4 arr2 np dot 3 4 5 6. What is the union of 1D? What is the union of 1D? 1 2 3 4. This 3 4 will not come again and 3 5 6 will come because set is a collection of what elements? Unique elements. So I'm going to take up here. I will take this data and I'm going to use it. This concept, finding the union. So finding the union. So here I'm going to take it. This I will write it. I'll try to use it heading as a question here. Finding unique values of two arrays using this function and try to find out. So union of elements is equal to, if you want I can write it. If you want I can write it. Subject and a symbol called what? Union, and I'll write like this is equal to like this dot format of what? ARR1 ARR1 comma what? ARR2 comma new array. So I can find 1 2 3 4 union of this one. I'm getting the answer like this. Able to follow? What is the function name here? Union 1D. How to find the unique elements of ND array? Unique function. Unique function. I wrote the code for unique function also. Are you following, students? Next. What is the next? Intersection. What is the function name? Intersection 1D. Union 1D. Already you learned union. With the bitwise operators, with functions, with the Venn diagrams also I taught in the class. Set of cricket players, set of tennis players, with Venn diagrams, bitwise operators, everything. So, listen. So, both of you need to listen. Right. Here I am going to take it, find the intersection of the following two sets. This is one array, this is another array. What is the intersection? 3 4, 3 4, 3 4. NP dot intersection of 1D. Pass what? ARR1 comma ARR2. And it is going to one keyword argument also there that you need not to write it. That you need not to write it. That means 2 times 3 4. 2 times 3 4 will not come. 2 times 3, 3 times 3 will not come. So that is only one simple thing they are saying. Assume unique is equal to what? True. That means unique values only will be taken into picture. So by default, assume unique is called what? True only. Unique elements only will be taken or not. So this need not to write it. Without writing also you will be getting it. So note, the intersection 1D takes an optional argument called what? Assume unique. which if we set to true, it can just speed up the computation. Suppose if we don't write this, it will check the value. Then it will go for what? True. After checking, then it will be true. Then it will be done. If you do here itself, it is just a little speed up the task. So it should be always set to true when dealing with what? Sets. So finding the intersection, I'm going to take it. So to find the intersection of it, I'm going to take it. This one I'm going to take it. So there I will take it. This data, intersection of these elements, you take it. Here I'm taking. Here I'm going to use it. Intersection of these things. New array related. There I'm writing intersection symbol is called like this. Something like, it is not there, I think so. Inverted of what? So n like this. So like this. This is going to be called what? Intersection. N I am using. N is nothing but intersection symbol like. And this part I will take ARR1 and next is called what? ARR2. So get the values. Answer is what? 3, 4. Are able to follow? Even you can eliminate this assume is equal to true. You can eliminate assume is equal to true. It is 3, 4 only. It is an optional parameter. If you want, you can write it. Otherwise, no need to write it. Just write that kind of thing. Right? This is known as what? Finding the intersection. What functions you know in the union set operations in universal functions? Unique of, come on, union 1D, intersection 1D. Discrete functions how many? Diff of array. Diff of array comma n is equal to some number of discrete differences. One more is called what? GCD. What is that? np dot GCD of np dot GCD dot reduce. What is the GCD over there? Object of which class? UFUNC. What is the lin ALG is called? Submodule. What is the random is called? Submodule. What is the NP is called? Module. Inside the module NP, 2 submodules. Random, lin ALG. Universal function GCD. NP dot GCD. Don't think that NP dot GCD is a module over there. It is a function. Okay, next, start. What is this now? Difference. Do you know the difference? Remove the common elements between two sets and take the first elements. Suppose S1 minus S2. S1 minus S2. See, 10, 20, 30. 10, 20, 30 minus, what is this now? 20, 30, 40, 50. What is the answer now? 20, 30 common elements. Remove remaining elements. Since S1 I am writing first, answer is called what? 10. 10. Suppose all of them are common elements here also. Result is what? Empty. Empty. If I write S2 minus S1, what is happening? 20 to 30 common. Remaining elements are what? 40, 50 is the common elements. So S1 minus S2 is not equal to S2 minus S1. But one thing you know, S1 dot intersection of 1D of S2 is completely different, same as S2 dot intersection of 1D also. Union also same property. Intersection also same property, but difference is going to be different property. That I already made it very clear in the beginning only. So, to find only the values in the first set, that is not present in where? Second set. We use what? Set diff 1D method. Set diff 1D method. How do you apply? Take the data, take the data, take the data. What I am applying? NP dot set diff 1D. Set 1 comma set 2. And set 1 minus set 2. What are the common elements? 3, 4. What is the answer? 1, 2. 1, 2. So I'll carry out this now. I'll carry out this now. Coming to this now. I'll take out this. I am writing, finding the difference. Finding the difference. Here, finding the difference. I'm finding the difference and I'll write this answer here. I'll write it. Minus, I will write it. Symbol called what? Minus. Minus I am writing. Set 1 and set 2. Set 1 here, set 2. Set 1 and set 2. And the next is called what? New array as usual. What is the data now? Set 1. Yes, set 1. What is the answer now? 1, 2. 1, 2. 1, 2. Are you getting 1, 2 or not? Next, same thing. I can go for changing the answer now. What it is going to be? Set to 2 and what? Set 1. So here I will write set 2, and next is what? Set 1. And answer is called what, you know? So set to 2. Set to 2. Yes. So answer is what? 5, 6. Common elements are removed and remaining elements are like this. Getting or not? So here also I am writing, for example, 1, 2 students. 1, 2 also I am writing. You will get what now? What is the, okay. So take it, go to this place and take it here. What is happening? Empty, empty. Getting up? So like that you need to take care, students. So this part we are feeling very easy because already we did a lot of explanation about what? Sets. Compared to that, this is just left hand, left finger here. What are the functions, you know? Unique of union 1D, intersection 1D, set diff 1D, set diff 1D. Next, symmetric difference. Symmetric difference is what you see. S1 is equal to 10, 20, 10, 20, 30, 40, 10, 20, 30, 40. S2 is equal to what? 30, 40, 50, 60. 30, 40, 50, 60. What is this now? S1, symmetric difference, just a symmetric difference. In mathematics, it is called a delta. It is a delta. That was already explained in my classes very well. Python concept it is. Set a difference of what? S1 comma S2. Remove the common elements and take out the remaining elements from both the sets. Take out the remaining elements from both the sets. 10, 20, 50, 60 is an answer. Okay. Come on to the point back. See that. Next one, symmetric difference. So, see, note that to find the values of what? That are not present in both the sets. And use what? Set XOR 1D. Set XOR. Have you heard about XOR in my class? Because you are all Muddu Babulu here, my Python students. Go to 7 a.m., 4 p.m., anywhere. Operators. Operators. In that, no sir will explain bitwise operators properly except me. When I'm saying this much confidently means you can look at how carefully I was explained. Bitwise XOR, truth table. Example number 1. Example number 2. Special points, symmetric difference. See that. See my Python classes. Here, bitwise XOR operator. Generally, these days, if 2 to like this, if I write, outside people will write 8. It is a blunder. What is the 2? 0, 0, 1, 0. What is the 3? 0, 0, 1, 1. Answer is what? 1, 0, 0, 0. Answer is called 1. And people are thinking outside it is an 8. And they can't believe even when we say normally. When we show practically, they will understand. They will understand. If we say normally, they will think, sir, don't know, they will think. It is a natural, because already they occupied by somebody else. Their brain was occupied by something else. Wrong they occupied. When we say truth, it will not. Because wrong they will listen very easy. Are you following? So, like that, see, I applied it. I applied on strings. I applied on these things. Swapping related with a swapping related with this kind of thing. And you know, students, the same thing when you come to data types. When you come to this anywhere, any class of mine, if you take it, data types, if you take it, there is a set data type. Problem solving using sets. Set of cricket players, set of tennis players. Last one you see. Find the players who are exclusively playing cricket and tennis. We applied which operator? Exclusive. This is by using union. This is by using intersection. This is by using difference. This is by using difference. This is by using symmetric difference. Solve the following problem with what operators? Super. Super. Union related. We are applying what? Bitwise OR. Union place, we are applying bitwise OR. Intersection place, we are applying AND. Difference place, we are applying minus operator. Here, we are applying symmetric difference. Here, we are applying what? That is what is called today. That is what is called today. Come on, set bitwise operators, sets. Which bitwise operator? XOR. What operation? Sets. On what? 1D. Combined together, what is the function name? Adi. They will ask a question. Why XOR? Why set? No, sir, I don't know. My sir said like that. If I go to an interview, I will explain the total story of what is Python. I'll tell bitwise operators and I'll come to this place. See, to understand such a small thing, how much story required? I can develop my own function as what? KVR XOR 1D also I can develop. KVR XOR 1D also will work like what? Set XOR 1D. Because internal I will use which operator? Bitwise operator I will use. Beautiful. So, do you feel difficult? Because my sir said already sets. My sir already said bitwise operator very perfectly. XOR operator with various examples. On 1D today I am applying. What a great topic. Find the symmetric difference between the sets array and I am applying that. So go to this. Finding the symmetric difference. Here I am applying. Symmetric difference I am applying. Here I am going to. Find the symmetric difference. How do you apply? Easy. Go to that. Now I am applying. Get this data. Here I am getting. So here, see this now. Getting this data. I am applying symmetric difference. So print this symmetric difference. Symmetric difference means XOR operator. XOR operator. Don't think in other way. So here I am writing this entire thing. What is the symbolic notation I am applying? Cap. That part is going to give you the result. What is the symmetric difference? Remove the common elements. What are the elements left out? So of course I have to write set 1. I have to write set 1 and set 2. Anything I can write it. No issue, students. I can write it. Are you able to follow? 3, 4, 3, 4 remove. 1, 2 and then 5, 6 is available here. Able to follow? This is the meaning. You can write set 1, set 2 also you can do it. There is no difference at all. This is called set 2, you pass it. Set 1, you pass it. There is no meaning difference in that. Same output will be coming. Same output will be coming. There is no difference at all. 1, 2, 5, 6. Here also 1, 2, 5, 6 will be coming. Understood that? And do you know, students, what is the function I am using? Set XOR 1D. This is indicated as what? You know, students, it is indicated as what? Set XOR 1D is equal to, indicated in the mathematics as delta. This delta is equal to what? Union operation minus intersection operation. Which one union? Which one? Here I wrote it. Set 1, comma set 2 written. Na? How do you write it that? Union of what? S1, comma S2. What is that? Difference of, what is this now? Come on. Intersection of what? S1, comma S2. This can be formulated like that. I will write it. If you follow me, my concept, I can write it like this. What is that? This equivalent formula for this is equal to, can be written as what, you know, students? Can anybody can answer my question? What is this now? Result is equal to, I am writing here. Tell me students, NP dot. What is the function I already applied? What is the function I already applied? Union. Union of what? Here I will carry. Here I will carry. Union of what? Set 1, set 1, comma what? Set 2, set 2, okay. After that, what I will write? Dot, dot. What I will write it? Difference I will apply. What is the difference function? Set diff. Set diff. I will write it here. What I am writing now? Dot what? NP dot set diff 1D of what I will write inside? Intersection I will write it. Intersection I will write it. This intersection I will carry. This intersection I will carry. Of I will write it. Come to the place. Here I will write it. Of what here? Set 1 comma set 2. Set 2. This is the one I will write it. This is the one I will write it. I think you are following. So this part, we want to look into the result. RES is equal to NP dot this entire thing, right as it is. Set 1 comma set 2. Union will found. Difference of what it will find? NP dot. This part will find. Dot. Difference will find of what it is. This part will be coming. And those things, this is found. After that, what will be applied? Difference will found. So I think dot I will write it. Then try to find out. Does not contain set 1 diff. Just a minute. I am trying to tell you like this. Just a minute, student. Union I will get it first. RES is equal to NP dot. This point you try to understand. I will take up RES comma type of RES I will get it. What is coming? ND array. Okay. That is getting. That is okay. After getting that dot, what I want to get it? Set. What is the function name? DIFF 1D. Of what I will write it? Intersection of that I will get it. Intersection of this I am getting. Intersection I will get it. Set 1 and set 2 I am getting. That part I am going to see. See the result what is getting. ND array object has no attribute called set diff 1D. Just for a minute, set diff 1D. NP is here. After that, it is going to give you this process will give you. It will take NP dot intersection of 1D. Line number here, 4th line. Dot difference of 1D, intersection of that. Just hold on. Just hold on. This point I will find out. I am splitting and finding the result. RES is equal to this one. Print of RES, type of RES. So I'm going to get 3, 4 ND array. Okay. Then I'll go for, this is also working fine. Then where is that is getting doubt now? RES. Now try to get it. Now I'm going to get it as no attribute. NP data. So that we should not. Because already that is object is coming. What I do is, just a minute, I will take up that. Difference of that, this point of this one. Try to get it. Set diff 1D is getting problem here. This object, set diff 1D. This result is separate. It is taking two things over there. Okay. Set diff of what? Set diff 1D. Set diff 1D is taking how many parameters? 2 parameters. But I gave you what? 1 parameter. Okay. Just a minute. This part I will carry. I am preparing the formula. You get it. You get it. Now you are getting it. Perfect. Now I'm getting RS. Now I understood. Print of RS. Print of RS. Answer is coming. Answer came. మీకు అర్థం కాలేదు అది. C. Come to the point. Dear students, what was my previous thesis అనేది మొత్తం remove మొత్తం తీసేసా. What is that question? Try to understand. What is this symmetric difference is? S1 delta B. S1 delta what? S2. This is called symmetric difference. What is the actual formula mathematics? S1 union S2 minus, what is that? S1 union what? Intersection of S2. What is the S1 union S2 of this data? First of all, you take this data, S1 and S2. This S1 and S2. This data, if you take it, Python కు వెళ్దాం ఒకసారి. అంటే I want to make you to understand here. This is a data. You take this data. 1, 2, 3, 4. 1, 2, 3, 4. S2 is equal to 3, 4, 5, 6. 3, 4, 5, 6. Next what? Symmetric difference. What is that now? S3 is equal to S1 dot symmetric underscore difference. Difference of what? S2. Print of what? S3. Comma what? Type of S3. In any of the order it will come. Okay. Same formula you can do in different way. I am saying S4 is equal to S4. S4 is equal to what I said. S1 symmetric difference of S2 is equal to mathematically denoted as S1 of what? S2. This is taken as what? S1 union S2 minus S1 intersection S2. What is the S1 union S2, students? 1, 2, 3, 4, 5, 6. Correct or not? Minus intersection is what? 3, 4. 3, 4. 3, 4, 3, 4 cancel. ఇక్కడ 4 కూడా ఉంటుంది. 4. 3, 4, 3, 4 cancel. What is an answer? 1, 2, 5, 6 is an answer or not? How do you do it mathematically? S4 is equal to S1 dot union of what? S2. This is Python. Dot difference of what? S1 dot what? Intersection of what? S2. S2. See the answer. Print of S4. S4, comma what? Type of what? S4. They got the same answer. This is a Python level. Numpy level. What the Numpy level says? Import what? Numpy as what? NP. Take S1. మళ్ళీ తీసుకుంటున్నా S1 for your clarity purpose. Come on. Find the symmetric difference. S3 is equal to what? NP dot. It is not taking S1 dot. NP dot. Come on. Set XOR 1D of what? S1 comma S2. Earlier it was taken as what? S1 dot symmetric difference. But it is taken both of them as what? Parameters here only. Because this is a function present into where? NP. Print of what? S3. Comma type of what? S3. It is an ND array. Are you getting this? S3 na? So what it is printing? Set XOR. What it is going to give you? So here I will write it. What it is giving now? Set XOR 1D. Same, huh? Is it the same function? Set XOR 1D. What is this now? Assume is equal to what? True. Assume is equal to true. Here I will write it. Assume is equal to true. So cannot be concatenated. What is this problem again? Import numpy. So say here S1, say S2. What is this now? np dot xor s1 comma s2, s1 comma s2, np dot this data. We are getting this. Assume is equal to true, comma. What is this now written? S1 comma S2 np dot set XOR this one. So got it. One dimensional array cannot be concatenated. What is this S1 comma S2? Okay, that's true. But what is this answer now? ND array objects or not? These are ND array objects. But I'm taking here what? Sets. Are you getting? Sets in ND array is not having dimension. So you need to take it as what? You need to take it as what? This data to be taken as what? To be taken as what? NP dot array of. So like that, S2 is equal to I say here NP dot array of what is this now? Like this, close. Are you following that? S1 and S2 are which type? ND arrays. I am performing ND array set XOR operation. Now you do. What is the next operation? Now you see. A set XOR takes ND array objects only, but not what? Set data type values? No. So, even you need not write assume and all those things. See the answer came. Print of what? X3. X3. Comma type of what? X3. Got it. Got it or not? This XOR, I am talking with what? This XOR denoted as what? Delta. Delta of what? S1 comma S2. What is the answer now? Delta says what? Union of what? S1 comma S2 and what? This will give you one result or not? This is one ND array. Next what? Intersection of what? S1 comma S2. This will give you one ND array object or not? Find the difference of. Because the difference will take two ND array objects. In where? Numpy. Got it? So, here we got it. In this case, this is a formula in normal Python. That is different here. What is that? Come on. What is that? S4 is equal to np dot set diff 1d. Set diff 1d. Getting? Next, np dot. np dot set union 1d. You need to go for what? Union. What is the function name for union? What is the function name for that? Union 1d. Union 1d. Union 1d. Of what? S1 comma what? S2. Because of that one answer will come or not? Comma. Next what? Intersection elements also I want. NP dot intersection 1d. Intersection 1d. Of what? S1 comma S2. S1 comma S2. So, what happens? S1 comma S2. Intersect 1d. Intersect 1d. Intersect 1d. Intersect 1d. Check that function once. Intersect 1d. Yes, intersect 1d. So, here, try to do this. Done. And don't expect when sir will write immediately answer. When you become a doctor, somebody has to go to garbage collector. Direct a doctor will not become. Doctor will make somebody else to be collected by garbage collector. So, intersection. So, it is suggesting also intersect 1d. So, print of what? S4, comma what? Type of S4. So, you are getting the same answer like previous. Which one this is? ND array. So, I am trying to say, I am connecting the normal Python with a Numpy. That is my intention. Sir, why all these things are set XOR 1D? Happy. XOR 1D, symmetric difference. What is the function name? XOR 1D. Are you able to follow now? So here, note. In all the times I am saying note point unique to be passed to speed up the computation, something it is saying. So what are the set universal functions? What are the functions? Here I am applying what? What are the operations? Unique of, next is called what? Union 1D, intersect 1D, diff 1D, set diff 1D. Next is called what? Set XOR 1D. These are all called what? Numpy related universal functions. Okay now? Fine. So next I'll go for the another one is called what, if we go to that universal functions, the Numpy exclusive universal functions, there is a set operations done. Some functions are there, some that I'll cover in the next class. And the next class I will be going for what? Rest of the 4 I will compute it. And today we learned what? Discretes, GCD, LCM, set operations we completed. And the next we'll go for what? Other kind of things we'll go for it. Don't miss it. So you also go to underground for 10 minutes. You also